This is our second lesson on trigonometry. Today we are going to talk about trigonometrical ratios and identities. By the end of this lesson, you should be able to 1. Define sine, cosine, tangent, secant, cosecant, and cotangent in terms of right angle triangles, points in a plane, and unit circles. 2. Determine the trigonometry values for any acute angle. And 3. Use trigonometrical identities in solving problems. Trigonometrical ratios. Trigonometrical ratios of an acute angle are ratios of different pairs of sides of a right-angled triangle. The 3 trigonometrical ratios are sine, usually use SIN to represent it. Then we have cosine, usually use COS as cos to represent it. And we have tangent, we use TAN as tan to represent tangent. These ratios may be positive or negative depending on the quadrant in which they lie. To find them for acute angles in a right angle triangle, label the sides of the right angle triangle as follows. Hypotenuse H, the longer side or the side opposite to the right angle. Then we have opposite, the side opposite to the angle under consideration. And we have the adjacent, the side next to the angle under consideration. Now this diagram is an example of a right angle triangle. So the longer side is the hypotenuse, as you can see. Then we have the opposite, that is the side that is opposite to the angle under consideration or in question. Then we have the adjacent, where the angle lies. So these are the 3 sides that we are going to use to define our trig ratios. Now let us consider the right angle triangle below to define the ratios. Now we start with sine. Now when you talk of sine theta, it means the ratio of the length of the side opposite to theta over the length of the hypotenuse. From the diagram, it means y divided by r. So that is the definition for sine theta. Then we move on to cos theta. So cos is also the length of side adjacent to theta over the length of hypotenuse. Now from the diagram, cos theta will give us x over r. Then we have tan theta. From the diagram, it is the length of side opposite to theta all over length of side adjacent to the theta. From our diagram, tan theta will be equal to y over x. The 3 other trigonometric ratios are the reciprocal of the 3 main ratios. They are cosecant, or cosec for short, and it is 1 over sine theta, or r over y. Then we have secant theta, or sec for short, sec theta, also 1 over cos, or r over x. Then we have cotangent, or cot for short, and that is 1 over tan theta, or x over y. We must note that these functions are less commonly used, therefore should always be replaced by their reciprocals. The values of these ratios are related to the corresponding acute angles with the x-axis. The signs of the ratios can be remembered using cast or auxiliary tomcats. You find the diagram below. So it's a form of mnemonics. Some may want to use CAST, for which we are calling the cast, or others will say auxiliary tomcats. Now the C stands for cos, the A stands for all, the S for sine, and the T for tan. So if you use auxiliary tomcats too, that is the first letters that you are talking of. So the all is for A, all. So all the ratios, S, only sine, T, only tan, and C for cos. Let us note that positive angles are measured in the anti-clockwise direction from the positive x direction, starting from 0 to 360 degrees. So this is the diagram we were talking of. Now we always start from the positive x-axis, so that is 0 degrees. Then our first quadrant will be from 0 to 90. Then the second quadrant will be from 90 degrees to 180. The third quadrant is 180 to 270. Then the last quadrant is 270 to 360 degrees. So you will see that the 360 degrees coincides with the 0 degrees. Now when you say all is positive in the first quadrant, then we are saying that all ratios, the sine, the cos, and the tan are all positive in the first quadrant. The second quadrant, it is only sine that is positive. So cos and tan are negative in the second quadrant. In the third quadrant, it is only tan that is positive. So sine and cos are negative in the third quadrant. And lastly, in the fourth quadrant, it is only cos that is positive. Sine and tan are all negative. Good. I hope we are following. So this has been explained further here. So in the first quadrant, all trigonometrical ratios are positive. In the second quadrant, sine is positive, whereas cos and tan are negative. In the third quadrant, tan is positive, whereas sine and cos are negative. Lastly, in the fourth quadrant, cos is positive, whereas sine and tan are negative. Let's continue. Now we move on to trigonometric ratios of special angles. The trigonometric ratios for the angles 0, 30, 45, 60 degrees, and 90 degrees, and other angles for which these are the associated acute angles. For example, 120 degrees, 150 degrees, 225 degrees, 300 degrees are used frequently in problems. So it is very useful to remember their values. So we move on to the special angles itself. Now, when we consider an equilateral triangle, I hope you know what an equilateral triangle is. A triangle with all sides equal and all angles equal. And we take each side to be 2 units. Then from Pythagoras theorem, or from our diagram, the base, which is BC, because there's a perpendicular from A to meet BC at D, each side will be 1 unit each. The 2 other sides will be 2 units. So applying Pythagoras theorem, the side AD will give us √3. So it means that if you want to apply the ratios, then we can have our opposite, we can have our adjacent, and we can have our hypotenuse, depending on whether we are measuring or using 30 degrees as our point of consideration or angle of consideration, or 60 degrees as our angle of consideration. From the triangle ABC, you see that if you take sine, you have already defined sine, that is opposite over the hypotenuse. So from diagram, you get 1 out of 2. Now cos 30 degrees, cos is adjacent over hypotenuse, so will give us √3 on 2. Then tan is opposite over adjacent, so it will give us 1 over √3. But we can rationalize the denominator and it will give us √3 on 3. So 1 on √3 is the same as √3 on 3. Good, let's continue. Now we move on to the same diagram, but this time our point or angle of consideration is 60 degrees. So we are using the 60 degrees in the same diagram. So sine 60 will give us √3 on 2. Cos 60 will give us 1 out of 2. And tan 60 will give us √3 out of 1. And we know that numbers out of 1 is the same number. Again, if you consider another right angle triangle, by this time it's an isosceles triangle and not equilateral, and the sides are 1, then the hypotenuse will give us 2, applying Pythagoras theorem. So from this diagram also, sine 45 degrees will give us 1 over √2. If you rationalize it, it will give us √2 over 2. So they are the same. Now if you also have cos 45, it's also giving us 1 over √2, which is also the same as √2 on 2. Then we have tan 45 degrees, which is equal to 1 over 1, which is the same as 1. You can see that you have not talked of cos 90. I usually say that cos 90 is 0. Why? I hope to get some answers from you after moving or reading through this presentation. Now let us apply what we have learned so far. For example, you have to find the values of sine 120 degrees, cos 240 degrees, tan 315 degrees, sec 120 degrees, and lastly sine 210 degrees. So from example 1, let us go through how you solve it. Now 120 degrees is in the second quadrant. Therefore, its sine ratio is positive. The associated acute angle with the x-axis is 60 degrees. So let us note it again. We take all our ratios from the x-axis, not the y. Therefore, sine 120 degrees will give us positive sine 60 degrees. And we know that sine 60 degrees is the same as root 3 on 2. I hope it is clear. Example 2. 240 degrees is in the third quadrant. Now if you look closely at the diagram, you see that from the positive x-axis to the other negative x-axis will give us 180. So the idea is that what will be added to the 180 to give us the 240 as given in the question, and it will be 60 degrees, because 180 degrees plus 60 degrees will give us 240 degrees. We are interested in that 60 because that is where we are picking our ratio, and it is on the x-axis. So because it is in the third quadrant, it means our cos is negative. So the associated acute angle with the x-axis is 60 degrees. Therefore, cos 240 degrees is the same as negative cos 60 degrees, which is also the same as negative 1/2. The third one, tan 315. 315 is in the fourth quadrant. Therefore, its tan ratio is negative. The associated acute angle with the x-axis is 45 degrees. Therefore, tan 315 is the same as negative tan 45 degrees, which is also the same as negative 1 on 1, which will give us negative 1. The fourth example, we have sec 120 degrees. Now this is part of the reciprocals we are talking of. Now sec 120 degrees is the same as 1 over cos 120 degrees. So we will apply our idea on the cos 120, and after that you just take it back or change it back. Now 120 degrees is in the second quadrant. From the diagram you can see it. Therefore its cos ratio is negative. The associated acute angle with the x-axis is 60 degrees. Therefore, cos 120 degrees is equal to negative cos 60 degrees, which is equal to negative half. Now, because we said sec is 1 over cos 120, we now go and substitute negative half. Now this will give us 1 over negative 1/2. And 1 divided by negative 1/2 will give us negative 2. Then the last one, sine 210 degrees. 210 is in the third quadrant, therefore its sine ratio is negative. The associated acute angle with the x-axis is 30 degrees. So here too you see that the top semicircle is telling us that it is 180. Then what is supposed to be added to the 180 to give us the 210, and it will be 30 degrees. Therefore, sine 210 degrees is the same as negative sine 30 degrees, which is the same as negative half from our special angles. Now we move on to basic trigonometric identities. An identity is a relationship which is true for all values of a variable. Now from our diagram, if we have a point P, xy, making an angle of theta degrees with the x-axis, with an origin point 0, 0, and r as the length or the radius, Then the equation of the circle will give us x squared plus y squared is equal to r squared. But it has been established that cos theta is equal to x over r and sine theta is equal to y over r. So we divide the equation of the circle through by r squared to obtain x squared over r squared plus y squared over r squared is equal to r squared divided by itself. This implies that x over r all squared plus x over r all squared will give us 1. Now, from x over r squared plus y over r squared is equal to 1, we can say that cos squared theta plus sine squared theta is equal to 1. Now here we can decide to make cos the subject to get cos squared theta to be equal to 1 minus sine squared theta, or make sine squared theta the subject to get 1 minus cos squared theta. From the identity cos squared theta plus sine squared theta is equal to 1, other identities can be derived from by dividing it by cos squared theta and sine squared theta to give. So if you divide through by cos squared theta, you get 1 plus tan squared theta is equal to sec squared theta. And if you divide by sine, you get cot squared theta plus 1 is equal to cosec squared theta respectively. That is to say that for the first one I divided through by cos, and the second identity I divided through by sine. Now you must also note that tan theta is the same as sine theta over cos theta. Now we must also note that sine squared theta is also the same as sine theta, all into bracket squared, and so on and so forth. Now let us also take an example on this. Now example 1, if sine theta is equal to root 3 on 2 and theta lies in the second quadrant, find cos theta and tan theta. Now solution. Now you have been told that sine theta is equal to root 3 over 2, but from one of our identities we know that cos squared theta is the same as 1 minus sine squared theta. So we substitute. Anywhere we see sine theta, we put root 3 on 2 there. So this will give us cos squared theta is equal to 1 minus root 3 on 2 all squared. Now cos squared theta now will give us 1 minus 3 over 4. And 1 minus 3/4 is the same as a quarter, or 1/4. Now, we are to look for cos theta and not cos squared theta. So therefore, to find cos theta, we find a positive and negative square root of 1 over 4, and it gives us plus or minus half. But theta lies in the second quadrant, therefore cos and tan are negative. Therefore cos theta is equal to the negative half, and tan theta now will be negative root 3 on 1, which is also the same as negative root 3. Alternative methods can also be used. We can also apply the Pythagoras theorem to find the third part of the right angle triangle. Then we continue from there. Example 2. Given that sine A is equal to 8 over 17 and that A is an acute angle, find cos A and tan A without using tables. Now, to solve it, we can sketch an appropriate right-angled triangle, and with the application of Pythagoras theorem, find the third side of the triangle. as I just said. So we can sketch. Our opposite was 8 and our hypotenuse was 17. So it means we will have to find the adjacent. And in finding the adjacent, we have x squared plus a squared being equal to 17 squared. Now making x the subject, we have x squared is equal to 17 squared minus 8 squared. Then x will give us the square root of 17 squared minus 8 squared. 17 squared is 289. 8 squared is 64. So the difference will give us 225. And the square root of 225 is 15. Therefore, cos theta will give us adjacent over hypotenuse, that is 15 over 17. And tan theta will give us opposite over adjacent, that is 8 on 15. The third example, simplify 1 all over 1 minus cos theta plus 1 all over 1 plus cos theta. Now here we use the idea of the lowest common multiple, or the LCM. Now the LCM for the two fractions will be 1 minus cos theta into brackets 1 plus cos theta. And 1 minus cos theta will go into the denominator 1 plus cos theta, plus 1 plus cos theta will also go into the denominator 1 minus cos theta. So we expand and simplify, and to give us 2 over 1 minus cos squared theta. And in one of our identities, 1 minus cos squared theta is the same as sine squared theta. So this gives us 2 over sine squared theta. And 1 over sine is the same as cosec. So therefore our final answer will be 2 cosec squared theta. Example 4. Show that 1 minus cos squared theta into brackets times sec squared theta is equal to tan squared theta. So if we are supposed to show in mathematics, then we either prove from the right hand side to the left hand side, or vice versa, the left hand side to the right hand side. Now if you start from the left hand side, then 1 minus cos squared theta is the same as sine squared theta, multiplied by sec squared theta is the same as 1 over cos squared theta. Now we are multiplying, so sine squared theta times 1 will give us sine squared theta over cos squared theta. And we said from one of the identities that sine over cos is the same as tan. Therefore sine squared theta over cos squared theta is the same as tan squared theta. So it is quite easily done. We are now getting the right hand side. Now let us summarize what you have learned so far. The trigonometric ratios are sine, cos, tan, and they are reciprocals, cosec, sec, and cot respectively. There are trigonometric ratios for special angles such as 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on. Some basic trigonometric identities are cos squared theta plus sine squared theta is equal to 1. 1 plus tan squared theta is equal to sec squared theta. Cot squared theta plus 1 is equal to cosec squared theta. And the last one, tan theta is equal to sine theta over cos theta. Let's take these exercises. 1. Find the value of cos 120 degrees without using tables. If angle A is between 270 degrees to 360 degrees and cos A is equal to 0.6, find sine A and tan A without using tables. 3. Simplify sec theta minus sine theta tan theta. I hope we do it and submit it next week. Now, don't forget to stay at home, be with your books, and if you want to go out, make sure you wear your mask and always wash your hands under running water and always use your sanitizer. Thank you very much. Hope to see you soon. Bye bye.